Alrighty, so now we're going to take a little turn away from logarithms, and now we're going to learn how to solve exponential equations. So for this topic, we're just going to worry about finding common bases, right? And then we'll learn how to solve exponential equations when we can't find common bases, right? But let's not worry about that right now. Let's just worry about this. So for our directions, we want to solve for x, and the example we're given is 2 to the 3x plus 1 is equal to 8. So before we solve this, I need to recall the equivalence of exponential expressions. So remember x, y, and b, they're real numbers. B has to be greater than 0, and it cannot equal 1, right? Then if I have b to the x equals b to the y, then we know that it's equivalent, so x is equal to y. Right, and that works. So for example, like if we had x is equal to y, that is also like if I had b and then I multiply, like make this a power each, then I can make this b to the x is equal to b to the y. That's essentially what we do with the e's. So if I can do e to the x is equal to e to the y. Right, so that's why that we can do that. Right, so that is the equivalence of exponential expressions, and let's go ahead and use this. So when I look at this, I have 2 to the 3x plus 1, and I have 8. So when I look at 2, 2 cannot be, 2 is a prime number, right? So it can't be, I can't write that as a power. So this is going to stay the same. So this actually helps me because then I know my next number, I have to find something so I can make it a base of 2. So 2 to the what is equal to 8, and in this case it is 3. Right, 2 cubed is equal to 8. So now we can use the equivalence of exponential expressions. So this, so since they have the same base, we can let the exponents equal. So we get 3x plus 1 is equal to 3. Right? So get x by itself. Okay, I subtracted 1 from both sides, and then I get x is equal to 2/3. Right? So in this case, so with exponents, we don't have to, there's no restriction on x. Right? B is the only one that has a restriction, so therefore we don't need to check it. But it's always good to check our work just to make sure we did this correctly. Okay, so we're going to do that now, so just quick checking. So 2 to the 3 times 2/3 plus 1, so 3 times 2/3, that's just 2. Okay, 2 plus 1 is 3. Okay, and we know 2 cubed is 8. Okay, so since these are equal, we know for sure x equals 2/3 is the solution for this example. Right, so that was this, and now let's look at another example where we have variables on both of our terms. Right, so let's look at example 2. Example 2, we have 27 3x plus 3 is equal to 3 to the 6x. Right, so I'm looking at these terms, so I'm looking at both at the same time. I'm working with 27 and I'm working with 3. Okay, 3 is also a prime number, so I know it cannot be reduced anymore. Can't be 3 to can't make it something to a power. Right, so I'm going to focus on 27. 27, so, and I wanted to have a base of 3. So 3 to the what is equal to 27. In that case, it is 3. Okay, this is 3x plus 3. Okay, because 27, we just rewrote it as 3 cubed. But, yeah, okay, so this can be 3. You can distribute the this if you want, doesn't matter. All right. So, but yeah, so the reason why I can multiply these is because of that exponent rule, the power of a power. Okay, so now that these are the same bases, what can I do? I can use the equivalence of exponential expressions, and I can let their exponents equal. So I get 3x plus 3 is equal to 6x. So this is why I didn't multiply out, is because I noticed there's a 3 here and a 6 here. They go into 3 goes into 6 nicely, so let's divide 3 from both sides. Then I get 3x plus 3 is equal to 2x. Right? Instead of having to deal with 9x plus 9 and just, yeah, right? But you can do whatever you would like. So in this case, I'm just going to subtract, actually, I'm going to subtract 2x over. I'll do one step at a time. Okay, I'll subtract 2x over, so I get x plus 3 is equal to 0. And then I'm going to subtract 3 over, so then I get x is equal to negative 3. Right? So let's check our work. I'll check it up here. All right, so I have 27 and then negative 3 plus 3, oops, 3 times negative 3 plus 3. Is this equal to 3 and then 6 times negative 3? Right, so 27 and then 3 to the negative 3, that is negative 9. Negative 9 plus 3 is negative 6. Okay. Negative 18. Okay, so I don't want to solve this, right? But I still know 3 cubed is equal to 27. Okay, 3 times 3 times 3 is 27. That I know for sure. Right, so I can multiply these together because the power to a power, so this is negative 18. This is equal to 3 to the negative 18. These are equivalent, okay? You don't need to find out what this value is, right? Especially because technically you're not allowed to use calculators, so therefore this is true. Right, so we did do our work correctly, which is nice. One thing I kind of want to show you guys is, so if you don't see that these are equal, I want to show you that if you distribute the 3, you'll still get the same answer. So I'm going to distribute the 3, then I get 9x plus 9 is equal to 6x. Okay, I'm going to subtract 9x over, so then I get negative 3x. And then so I get negative 3 is equal to x, because I divided both sides by negative 3. Also over here, if you wanted, you could have also just subtracted 3x over, then you would have gotten 3 is equal to negative x and divided both sides by negative 1. Right? So as you can see, multiple ways of doing things, but that is how you solve exponential equations when you have variables on both sides. So this one I just really want to emphasize over here. Right? So 27, I just put this in parentheses, okay? That's like the 3 cubed, so essentially I just kind of made that in parentheses and I rewrote it as 3 cubed and I just brought this down. Right? You can't drop it. If you drop it, it won't be the same. You can't just put like the 33x because obviously that's not the same. All right, so just is the safest way is just to put the number you are kind of modifying in parentheses. All right. So one thing, so we saw the basic example of just we just saw the basic example, and this one we got a little harder when we had variables on both of the terms. And then now I just want to do one final example of this topic, right? And that is when, so example 3, so we'll just talk about it after I write it. So 32 negative x plus 4 is equal to 64, right? So when I look at 32 and I look at 64, so 32 smaller, so in 32 smaller, and when I think 32 squared, 32 squared is definitely not, okay, sorry. So because 32, so 64, I can't reduce it to make it 32 to something power, right? That makes it equal to 64. So one thing about this one is that I notice they're both even, right? And then I know my 2's fairly well, so I know that they both are, I can do 2 to a power to make them equal. So in this example, it just shows how how both of them will need to be modified a little bit, right? So 32, what can 32 be rewritten as? It is, I think, 2 to the 5th. Oh my gosh. Okay, 2 to the 5th. And then 64 can be rewritten as 2 to the 6th. Yeah, right? So then I get 2 and then 5 negative x plus 4 equal to 2 to the 6th, right? So in this case, we had to modify both of them, but that's all right because we are still able to find a common base. And now what we're going to do is, now that we have the common base, we can equate the powers. So I have 5 negative x plus 4 is equal to 6, right? Unlike example 2, 5 does not go into 6 nicely, so what I'm going to do is I'm going to distribute this 5. And so I'll get negative 5x plus 20 is equal to 6. Right, so I'm going to subtract 20 from both sides. That gives me negative 14. Right, so if I divide 5 from both sides, I get 14 over 5. Right? Right, so now my solution says it's correct, but let's check it just in case I put a typo. So let's check it. Okay, we have 32 negative 14 over 5 plus 4. Okay, I'm going to just be a little lazy, so I'm going to already have a common. So I notice I have to add with fractions, so I'm just going to change it right away. So this becomes 20 over 5 equal to 64. Right, when I do that, so I get 32, and then negative 14 fifths plus 20 fifths, that's 6 over 5. Is this equal to 64? Right, so 32 to the 6/5, what is that? That is 32, the 5th root of 32 times 6. Right, I think it's easier to find the 5th root of 32 as opposed to finding the 6th power of 32 and then find the 5th root of that. So what is the 5th root of 32? The 5th root of 32 is 2 because 2 to the 5th is 32. Right, and then what is 2 to the 6th? 2 to the 6th is 64. So this is, it satisfies our equation, so therefore we know x is equal to 14/5 is the solution to our equation, right? So that's it for solving an exponential equation by finding common bases. However, life is not always that nice, and so we'll have to know some tricks to solve it when the bases cannot, when we cannot find a common base, and we'll talk about that in the next topic.